All right, how's everybody doing? Professor Brian back with another installment of Workout Wednesday. We're still in the organic realm. This last nomenclature video is going to be utilizing the name to then create the line structure and condensed formulas. So we're going to be utilizing the name to create the line structures and condensed formulas. Okay, so let's take a look. All right. First example here we have is 3,4,7,9 tetrabromo 7-ethyl 4-decene, right? 4-decene. So suffix tells us that there's going to be a double bond, right? And prefix to the suffix tells us it's going to be 10. So we're dealing with a single double bond, 10 carbons, and the substituents. So best thing to do here, noticing that we only have a double bond, so we don't have to worry about hybridization and the bonds being straight, we can just get 10 carbons on here. 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And some of these are a little longer than other ones, and that's okay, right? As long as we have the 10 we need. So we know that at 4 there is a double bond. And if we are numbering these from left to right, let's go ahead and number these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So we got them numbered. We know at 4 that there's a double bond. Okay, got that taken care of. We know that at 3, 4, 7, and 9 there are bromines. So 3, 4, 7, and 9, we can put our bromines. And at 7, we also have an ethyl group. And there we have our molecule, right? Again, if we numbered it from the opposite direction, the double bond would not have the lowest value, lowest number, and then it would be incorrect, right? So, again, 10 carbons, 1 double bond, and then our substituents as a function of the number of the carbon that they're at, right? Okay. All right, let's take a look at the next example. Really long, kind of long name here. But again, don't let that intimidate you. Just follow your rules. Follow your rules. So we see here diene, so we know we're getting some triple bonds. We also see nonene or diene, excuse me. Diene we know is triple bonds. Nonene we know has double bonds. So we're dealing with a molecule that has both. We got 9 carbons, right? We got 9 carbons. So we know we got 9 carbons. And we got 1 double bond and 2 triples. Now, because of that, we got to take into consideration the overall structure here, right? We got to take into consideration the overall structure. So, if we know that the triple bonds are at the beginning, right? We know that they're at the beginning. 1, 3. We can go ahead and take care of those at the beginning. We know after that, we can go back to what you expect to see because we don't have any triple bonds after that, or we don't have any triple bonds, so we should expect to see kinks until we get to 9. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, we got 9 carbons. Let's go ahead and number them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now we want to take a look at 8. Remember, we have a double bond, 8 nonene, right? So let's go ahead and put that double bond in there. All right, and then our constituents are at 6 and 7. So we got 6,6-dimethyl. And then we got 7,7-dichloro. And we have a finalized complete molecule. All right, finalized complete molecule. Now, just for example, just for practice, for this one, I will write the condensed formula, right? And the condensed formula should look like CH, C, 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 CH2, C, and you can write CH3, 2 here if you want to, C, Cl2 there if you want to, CHCH2. And that will be your condensed formula for that particular molecule, right? And again, you can write these off to the sides if you would like to. But that is that molecule nomenclature. Okay. Now, don't get so caught up in some of the more difficult examples that you can't do a simple example, right? This looks like a pretty straightforward example. We're dealing with octane. We do not have any double bonds, so we're dealing with 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. We can number them. 1, 2, 3, 4, 5, 6, 7, 8. And it says 4,4-diethyl. Done. Condensed formula here. CH3, CH2, CH2, C, CH2, CH3, CH2, CH3, CH2, 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 CH3. And we got 8. 1, 2, 3, 4, 5, 6, 7, 8. All right. Simple one. Okay, last but not least. Here we have 1,1-diiodo, 2,5-dimethyl, 1,4-hexadiene. Okay, hexa. We know we're dealing with 6 carbons. Diene, we got 2 double bonds. All right, got to take that into consideration. And a lot of this is happening at 1 and 4. So 1 is going to have a double bond. We got 6 carbons, 2, 3, 4, 5, 6. So that's the 6 carbons. At the 1 position, we got 2 iodines. And let me number these before I get ahead of myself. Don't get in the habit of getting in a hurry like me. We got 1, 2, 3, 4, 5, 6. Three, nothing. But we got 2 and 5 methyl groups. So at 2, we got a methyl group. At 5, we got a methyl group. And at 4, there's that other double bond here. Okay. So we have handled everything that we were looking for. All right. Now, remember, I did not go into cis-trans isomerism. I did not talk about that. These are very basic nomenclature. They do not involve the cis-trans because this is not an organic class. When you get to organic class, they're going to add some more to this particular situation. If we want to talk about the condensed structure, Ci2, C, CH3, C, H2, CH, C, CH3, C, H3 would be the condensed form formula for this particular example. Okay, so that is the nomenclature examples to get to the structures. And again, if you have any questions, feel free to send me an email, leave me a comment. It's just practice makes perfect when it comes to organic chemistry.